Lyryx, Lab 12, question 5. In this question we see that the lease has still 4.5 years left, and the company that has that lease still has 11,807 remaining on that lease. That's present value due, and the company cost of borrowing is J equal 15% compounded monthly. That's CLY is 12, and the lease payments are at the beginning of each month, so that's PLY is equal to 12. So we could see in here that PLY is equal to CLY. Therefore, we're going to use I in our formula. So we copy down the formula for present value due for annuity and due simple, because PLY is equal to CLY, so using I in here, I is going to be equal to 0.15 divided by number of compounding periods per year, which is 12. Payment is unknown, we have to solve for payment, so payment is unknown, payment is 0, and then PV due is equal 11,807, and N is equal to P over Y, number of payments per year, times number of years. So in this case we have a 12 payments per year times 4.5 years. And if you were to show some kind of diagram for this, it will show timeline. At time 0 today, they still have present value due outstanding balance equal to 11,807, and they're going to be making payments every month at the beginning of every month for, we calculated in here 54 payments, so N is equal to 54. Future value in here, once they finish paying, future value is going to be equal to 0, and those payments are at the beginning of every payment interval, and there are 54 payments. The last payment is at the beginning of 54 payment interval. Now we just have to solve for payment. Now we're going to substitute all the given values into this formula. So inputting those values, N is equal to 54, 54 for N, 15% for nominal rate, second function IY, and we have 12 payments per year, which is correct, and 12 compounding periods per year. The next one is present value is 11,807. Payment is 0, that's the one we're solving for, and future value is 0, and compute payment. The payment is $298.27. If you're using TI-8384, we input all these values, N54, I15, present value 11,007, future value 0, P over Y 12, C over Y 12, and begin. And then we scroll to payment, and alpha enter, and we get the same value, 298 and 27 cents. Question 6. This is Cleveland wants to accumulate, so therefore its future value of 512,000, and the interest earned is 12%, so that's J, compounded semi-annually, that's C over Y is equal to. She is prepared to make 278 equal monthly payments, so N is equal to 78 monthly payments, that's P over Y is equal to 12, and contributions at the start of each month, so that's BGA, therefore future value due is equal $512,000. I want to calculate payment. So if we write the formula, now we're looking for future value due. So future value due is going to be equal to payment times 1 plus, because P over Y is not equal to C over Y, number of compounding periods per year is not equal number of payments per year, use I sub 2. See, in our formula we're going to use I sub 2, so it's 1 plus I sub 2 to the negative n minus 1 divided by I sub 2, and then times 1 plus I sub 2. And again, we're solving for payment, so we're dividing both sides by this factor. So if we rewrite this formula, solving for payment, we have to divide both sides by this factor, and then substituting values. And now we have to just show calculation for I sub 2. So if we grab a calculator and do the calculation for I sub 2, I'm going to just reuse it what I had before. So now we have 1 plus, the nominal rate is 0.12, 0.12 divided by 2 to the power of 2 divided by 12, and then minus 1, and enter. So that's the I sub 2, and I want to store that, store in alpha x squared under I. So my I sub 2 is equal to 0.00972. So we'll do that, and do the same thing with business analyst 2. So first thing, you want to make sure you clear your memory. So 0, store in memory 2, so we'll erase anything that you have in memory 2, and then left bracket 1 plus 0.12, 12 divided by 2, right bracket, exponent by x, bracket 2 divided by 12, right bracket, and then minus 1, and equal, and then store in memory 2, so it's like I sub 2, and we have exactly the same answer as before. Now at this stage we can go and use calculator, so we'll go second function, clear TVM, and we have 278 for N, 278 for N, 12% for nominal rate, percent y. Then second function, pi over y, and we'll have 12 payments per year, that's correct. And then scroll down, we'll have 2 compounding periods, so we'll have to overwrite, enter, and the next one is 0 for present value, and then 0 for payment, and 512,000, 5, 1, 2, 1, 2, 3 for future value, and then compute payment. So the payment is $356 and 59 cents. And if you're using TID 384, you input your values and then scroll to payment, alpha, enter, and you have the same answer, 356.59. Now if you want to see a cash flow diagram, so on the cash flow diagram, we're going to show that at time 0 we have a present value equals 0, and the first payment starts at 0, which we don't know the size of that payment, but we do know that we have a 278 payments. The last payment is at the beginning of last payment interval, which is at the beginning of 278 payment. And at the end of 278 payment interval, we have a future value due, which is going to be equal to $512,000. And then we show that nominal rate is 12%, P over Y is 12, C over Y is 2, P over Y not equal C over Y. Use I sub 2 in our formula, and we calculate I sub 2. And that's all what we have for lab 12.